Here we are going to discuss properties of definite integrals. Property number 1, P1, integral a to b f of x dx equal to integral a to b f of y dy. F of x and f of y are integrands. Here you can change the variables x to y or y to x into any variable. For example, integral 0 to 1 x dx is x squared by 2, 0 to 1, that is 1 by 2. Similarly, integral 0 to 1 y dy equal to, it's also 1 by 2. Therefore, you can easily interchange the variables in the integrand. Next, property number 2, integral a to b f of x dx is, if you can interchange the limits. If you interchange the limits, that is a to b, if you change as b to a f of x dx, then you will get a minus sign. Property number 3, suppose a and c lies between a and b, then if you have integral a to b f of x dx, then we can split the integral. That is, a to b can be split into a to c and c to b plus c to b. That is, integral a to b f of x dx equal to integral a to c f of x dx plus c to b f of x dx. That is, this is the example. Integral 0 to pi by 2 x dx is equal to integral 0 to 1 x dx plus 1 to 2 x dx, because 1 lies between 0 and 2. Property number 4, very interesting. Integral minus a to a f of x dx is, if f of x is even, you can directly write as 2 into 0 to a. This lower limit 0 is preferred always. That is 2 into integral 0 to a. Minus a to a, in between we have 0. Therefore, 2 into 0 to a f of x dx, if f of x is even. Then integral minus a to a f of x dx, if f of x is odd, then it becomes 0. How to find out whether even or odd? Say, in the place of x you substitute, in the place of x in f of x you substitute minus x. If f of minus and f of equal to f of x, then x is even. If f of minus x equal to minus f of x, then in this case x is odd. That's all. Property number 5, very important, very useful property. Integral 0 to a f of x dx can be written as 0 to a in the place of x. Here the lower limit should be 0. Upper limit, if we have a, f of x can be written as a minus x. Suppose integral 0 to 1 x dx is 1 by 2. 0 to 1 can be written as 1 minus x. Upper limit is 1. Therefore, in the x place you can write 1 minus x. It is also equal to 1 by 2. That is, integral 0 to a f of x dx equal to, says lower limit should be 0. Integral 0 to a f of a minus x. Upper limit minus x dx. Now, next problem number 1. Without evaluating the integral, prove that minus 1 to 1 sin cube x cos x dx equal to 0. 112, problem number 1. Integral minus 1 to 1 sin cube x cos x. Sin cube x cos x dx. Here f of x equal to sin x. Let f of x equal to sin cube x cos x. Now you substitute, let us find whether it is odd or even. F of minus x equal to sin cube minus x cos minus x. In the place of x you substitute minus x. Sin minus x is minus power 3, odd number. Therefore, this is minus sin cube x. Cos, always cos of minus x. Cos swallows minus. Therefore, cos x. That is, this is equal to minus f of x. That is, f of minus x equal to minus f of x. Therefore, f of x is definitely odd. If it is odd, it is given that minus 1 to 1 an odd function sin cube x dx cos x dx equal to, how to write? That is, odd function means it is 0. That's all. This is cos x. This is 0. That's all. Properties of definite integrals. Using the 5 properties, we are going to solve problems easily. What are the 5 properties? Let me repeat. That is P1, integral a to b f of x dx equal to integral a to b f of y dy. We can interchange the variables in the integrand. P2, integral a to b f of x dx is, if you interchange the limits, you have to put a minus. Then P3, if a in between c, a and b, if there is c, then integral a to b f of x can be split into integral a to c f of x dx plus integral c to b f of x dx. Now, minus a to integral minus a to f of x dx are even, then it is 2 into 0 to a f of x dx. If it is odd, then its value is 0. Fifth property is important, lower limit should be 0, integral 0 to a f of x dx equal to integral 0 to a f of upper limit minus x dx, that is all. Now, problem number 1, that is integral sin squared x dx equal to pi by 2 equal to cos squared x dx. Now, let we take this first one as I, integral 0 to pi by 2 sin squared x dx. We apply p5, that is integral 0 to pi by 2 sin squared. A is here upper limit is pi by 2, therefore pi by 2 minus x. Using p5, integral 0 to a f of x dx equal to integral 0 to a f of a minus x dx. What is sin pi by 2 minus x? Sin pi by 2 is cos x, therefore cos squared x. Here that is sin squared x is integral 0 to pi by 2 x is 0 to pi by sin squared x dx equal to integral 0 to pi by 2 cos squared x dx. We have to show that each is equal to pi by 2. What is I? This is also I, equal to I. Now, I equal to integral 0 to pi by 2 sin squared x dx. These two are equal, therefore this is also I. Adding 2I equal to integral 0 to pi by 2, you can add these two inside the same integral sin squared x plus cos squared x dx, isn't it? Sin squared x plus cos squared x dx is 1, therefore dx, that is x 0 to pi by 2, that is equal to pi by 2, therefore I equal to pi by 4, and there is a mistake here, this be pi by 4. That is integral 0 to pi by 2 sin squared x equal to integral 0 to pi by 2 cos squared x, and each is equal to pi by 4.